Question is, we are missing, we have Dhanushri, Chris, Aryan and Arya missing for the kids. We'll hope they will join. Yeah, here comes Dhanushri.
She's joining.
Okay.
No, he's joining.
Arya is also here. So I think.
Hi,
Yeah.
sir.
Avita.
Hi, sir.
Hello, hello. So what are we going to learn today? So again, just a reminder to you all. We have detailed SAT prep 13 units. That's what is the boundary of this course for you all. And I'm not going in a sequence because there are topics which are much easier than other topics. So that's why what we have done is for this calendar year, let's say till December, what we'll do is I have given you guys the chance to decide which topic you want to pick up. Hey Rehan. So I request you all to go through the detailed necessity prayer, pick up the topics that you would want me to cover in this class. I already have some topics shared by Pranit and Arya, and that's what we are doing right now. So, but everybody in the class has equal opportunity to decide, choose the topic of their choice that they would want to, that they would prefer to cover early. So please, send me a WhatsApp with the topic that you would want to pick up. Otherwise, the topic that I have right now, I'm going through that one by one. So we covered unit and measurement, and then we covered system of equations. Then we looked at circle theorems. Right now we are going to talk about the fourth topic, which is unit circle trigonometry. That's what it is called. So that's the topic we'll pick up today, and we'll go through that, and then towards that we will try covering some of the standard formula for circles and see how do we want to deal with them. Yeah. Is everybody with me so far? Are we okay with that approach?
Yes.
And anybody and everybody in the class, you guys have the flexibility to join the pre-calculus class, which happens on Wednesdays, 7 to 8 p.m. Some of you have already started joining. Rest of you who want to join, please feel free to.
Wait,
Yeah.
is it like, wait, I forgot how much do we have to pay for that?
You don't have to pay. See, all my existing students, they don't have to pay anything extra, okay? I don't talk about money with you guys. So if I am saying there's extra class for you, that is an additional advantage you have. Okay?
Is it on Wednesday?
Wednesday 7 to 8 p.m. Yeah.
Oh, I have extracurricular activities, so I'm not free any Wednesday.
Right. No, that's fine. I mean, I'm saying this is an option. Some of you who are able to join, you're welcome to join. Some of you who are not able to join, you can always go to watch the videos offline and let me know if you have any questions, anything that is not clear. You can always reach out to me, and we'll try solving those problems for making the concepts easier, better for you. Okay. And again, remember one thing: I don't teach for money, so none of you will talk about money with me. If there's money involved, I'll reach out to your parents. Okay. If I'm telling something to you guys, that is without money into consideration. All right. Yeah.
Okay, thanks.
Yeah. All right. So let's get started. So let's look at circle. See, somehow I have built that skill of drawing decent circles. Okay. By teaching you guys, I never had that skill before. This is a circle, and everybody knows if I make one complete revolution, meaning start from here, go to the end, we are making 360 degrees. That's a measurement degree. What we're going to learn about is what is radian. What this angle that is 360 degrees, you can represent that in radian also. Does anybody know how much is 360 degree? How much is the complete circle making in radian? Anybody?
2 pi.
2 pi. Okay. So what happened was my screen got locked, so I cannot see who is talking. Ah. Alright. So 2 pi. Now Interestingly, this 360, so that is the right answer. So this angle is, which is 360 degree, one complete revolution of a circle is 360 degree. It can also be represented as this 2 pi radian, 360 degrees or 2 pi radian. And you will see that radian is also used interchangeably in trigonometry. So you will trigonometry and geometry both. So we should not get stuck with anything that says okay. I mean, if you have been asked to find out, let's say if you have been asked to find the value of sine 30 degree, everybody knows it's 1 by 2. Now if somebody says sine pi by 6, how much is that? So you have to basically you have to be very clear about this relationship between the degree and the radian, and you should be able to convert that to degree and then able to derive the value for that, right? So that's the main purpose of radian. So you will, in SAT you will find questions which says I am making an angle of 3 pi. Tell me how much is that in degrees. So as you know, 360 degree, yeah, somebody saying something. No? Okay. 360 degrees equals to 2 pi. So if you have to convert that, you know that pi equals 180 degree. Yeah, Ritika.
So that should be 540, right?
Yes, correct. So that's what I'm saying. So one, you have to just convert. You have to be very clear about this conversion. It's another, I would not say unit. It's not related to units and measurement. It is actually, because I mean you can measure the angles in degrees and you can measure that in pi. So it's another unit conversion that is coming into play here. So now you can, I mean there's nothing more that I have to talk about this, but yeah, as long as you know this relationship, that you can always use. So we will try relating that with, let's say, if you're talking about, let's look at a simple example of all the circle theorems, circle properties that we have dealt with. They can be dealt in degrees or it can be dealt in radian as well. So if you are talking about, let's say, an angle of pi by 2, 90 degrees. Yeah. So now let's try relating that with what you will come across more often, because let's look at the degree thing. Let's look at the trigonometry table to relate that with the pi, and so that it just helps you get used to it. Okay. 0, 30, 45, 60, 90. Okay, let's look at the sine value, sine, cos, and values for all these, and then we'll relate that with the radian real quick. It might be a little boring exercise for some of you, but we have tried proving how those values are derived. We are not going to do that exercise again, but we'll just try looking at the value of the different sine, cos, and tan for the standard values, and then try relating that with the radian and see if it resonates well when it comes to the conversion part of it. So if sine 0 is how much? Who knows? Who remembers? Yeah, go ahead, Ishwari.
Would it be the same as 360, so 2 pi?
No, so I'm saying the value of sine 0. Sine 0 degree equals how much?
Oh.
It's 0. Sine 30 degree equals 1 by 2. Sine 45 equals 1 by root 2. Sine 60 equals root 3 by 2. Sine 90 equals 1. Yeah? Who all is not able to recall? You're able to recall? Not able to recall. Okay, fine. So this is a standard table. I mean, let me put the value. And what happens is, uh, this is the no, the complementary angle theorem that we have learned before. So sine of theta is equal to complementary cos of theta actually. So sine 0, I mean complementary is like 0, sorry, some angle theta, the complementary angle for that is 90 minus theta. Okay? I'm not saying sine 0. So if theta is an angle, complementary angle for that will be 90 minus theta. So that these two together makes 90 degree. So when you talk about two angles as complementary, essentially you are saying that sum of the two angles is 90 degree. Yeah. So let me see who. Okay. Chris has still not joined. That's fine. So basically, so here this is how it goes. So this whatever value you are seeing that gets reversed. So we'll probably spend 5 minutes to, not 5 minutes, maybe another 20-25 minutes to see how these values are derived. But let me put the values first and then we'll look at what is the reason for those values. Now sine of 0 will be equal to cos of 90. So sine of 0 will be equal to cos of 90. And this whole table reverses actually. So sine of 0 is cos 90, cos of 0 will be sine 90. So this becomes 1. Sine of 30, cos of 30 would be cos of 60. So 30 plus 60 makes it 90. So it will be root 3 by 2. 45 will be same because 45 plus 45 makes it 90. And then sine of 60 would be, cos of 60 would be sine of 30. That will be 1 by 2. So what you can see is, whatever you have plotted here, that just gets reversed. Okay? And then 10 anyways, you know, sine by cos is 10. So sine by cos is 10. So 0 by 1, this is infinity. No, 0 by 1 is 0. My bad. So this will become 1 by root 3. This will become 1. This will become root 3. And this will become infinity. Yeah. Now, again, just giving you this table would not go well. Some of you will think from where this table came into existence. How and why we should believe this old teacher who's saying that sine 30 is 1 by 2, correct? Or sine 45 is 1 by 2. Let's look at some of these. And we have tried proving that in the previous class, but let's look at it real quick. Are you guys wanting to learn about that, or you don't want to? Okay. So this is the most boring part of my teaching, where whenever I see some of the students are not clear about any concept or has not come across that in the past, even if it's a repeat telecast for some of you, I kind of end up doing it so that I feel more confident. So let's say sine 0 degree, sine 0 degree equals 0. This is what I'm saying. Now look at this. What if you are looking at, or let me not put it this way. This is my right angle triangle. If this is my theta, sine theta equals the side opposite to that divided by hypotenuse. Let's say this is A, this is B, and this is C. So sine theta equals the side opposite to that divided by hypotenuse. This part everybody knows, right? Sine theta is, yeah, so cut over, or whatever you guys know. I mean, whichever way you guys remember it. Now, if I say sine 0 degree, meaning what does it mean? Meaning this angle is so small that it literally falls on this guy. Meaning this height is literally 0. So that's why sine theta or sine 0 degree, when you say 0 degree, meaning you are making these two lines fall. The hypotenuse literally falls on this guy. So basically this height becomes 0. So 0 divided by, let's say, my hypotenuse C. That will be nothing but 0. Yeah? Make sense? Okay. Similarly, now, another thing to remember, I said sine of theta is equal to cos of complementary angle. Meaning if this is theta, this, let's look at this. This is, let's say this is A, this is B, this is C. Sin theta equals A by C. Cos theta equals B by C. And tan theta equals A by B. Yeah. Now, I have to figure out how do I avoid locking up my screen. Okay, so now look at this one. If this is theta, then this angle is 90 degree minus theta. Okay, we are talking about right angle angle. So here, if sin theta is what? If I look at theta, sin theta equals A by C. Now look at cos. If I take this as angle, cos of 90 degree minus theta will be equal to, again, cos of any angle, cos theta of any angle is equals the base divided by hypotenuse. That becomes A by C. So you see, sin theta is equal to cos 90 by theta, and both have same value. That's why it is said that the complementary of cos theta, sin theta is equal to complementary of cos theta. That's why that's the thing. Yeah. So now, so that's why if you got sin theta, sin 0 degree equals 0, that will be equal to complementary of cos 0, cos 90. Cos 0 degree will be equal to sin of 90 degree minus 90 degree. What am I doing? What am I doing? Yeah. So sin 0 degree will be equal to cos 90 degree minus 0, meaning cos 90 degree. So whatever value we got for sin 0 degree, that will be the value of cos 90 degree. That's why we saw the value reversing, or flipping basically. Yeah. Now let's look at sin 30 degree. I said sin 30 degree equals 1 by 2. Now let's look at it. Let's say this is 30 degree and this is 60 degree. Okay. Now, other thing that we know about the property of the triangle is the angles are in the same proportion as the sides. Meaning, if you look at this angle, this is the biggest angle. So the side upper to that will be the biggest of all. If this is the smallest angle, you will see that the side upper to that will be the smallest. Meaning, the length of the side is in the same proportion as the angle. Bigger the side, bigger is the angle upper to that, or vice versa. So, if you look at a triangle with 30 degree, that means this is 60 degree. So, the length of this side will be half of this side.
Sir?
Yep.
You froze, so I didn't understand what you said because you froze. The screen froze.
Okay, can you hear me okay now?
Yeah, but like I couldn't understand what you said before because
Just before this one? Okay.
yeah.
So what I was saying was, any triangle, you should see. Let's pick up an obtuse angle triangle, okay? And this can be a very handy information for you all. If you have this triangle, don't worry about anything else. Just observe this triangle. What you see is, this is the biggest of all the angles, right? This is my obtuse angle. Okay. So the side upper to that will be the biggest. If you see this is the smallest of all the angles, then the side upper to that will be the smallest in that triangle. If you see this is the medium size angle, meaning bigger than this but smaller than this, then the side upper to that is of medium size. Meaning any side in the triangle is proportional to how what is the ratio between the angles basically. Now that means if I look at right angle triangle where this angle is 30 degree, this is 60 degree, this is 90 degree, right? This is my 30 degree. So side upward to this is this one. Let's say this is A, and side upward to this one is B. Okay, this is B, and this one is hypotenuse is C. Now this is 30 and this is 60. That means the side upward to this and side upward to this, they have a relationship, meaning A by B if I see, meaning A is half of B. So A by B will be 1 by 2. Okay? Or if I say B by C will be, okay, I'll not say half, 1 by 2. So if I say A by B, so side up, angle upward to this is 30 degree, B side angle upward to that is 60 degree. So this is the same proportion. So that is how it becomes 1 by 2. Now, if you look at I'm just thinking that shall we use this approach or this will actually get confusing. Okay, fine. Let's not use this approach. This is not right. Okay, this is certainly not right. This will not give you. You have to just know that relationship that okay, if this is the smallest angle, then the side upward to that will be smallest. That's the relationship only. Okay, let's not use that as a formula. That might not be 100% correct. Now let's look at this one. So we are saying sine 30 degree equals how much? Sine 30 degree equals A divided by C. Now, how much is the value of A? We don't know. How much is the value of C? We don't know. I will not go by the relationship. It's not the ratio. It just says which one is bigger, which one is smaller. What we will do is, let's try proving this theorem. Let's try proving the value. What we will do is, let's draw a perpendicular on this one. This is 30 degree and this is 60 degree. Let's say this was my triangle ABC, and this is, if I draw a perpendicular, that is 90 degree. This is also 90 degree. Now, what do you see here? This is 30, this is 60. So what will be the value of this one? This will be 30 degree as well. Yeah? If this is 30, this is 90, this will be 60 degree. Yeah? So, here, if I look at this triangle, let's say triangle BCD and triangle ABC, the bigger triangle, what do you see? They are similar triangles because this has 30, 60, 90. This larger triangle also has 30, 60, 90. They are similar, meaning the sides will be the same ratio. When you have two triangles similar, their sides will be the same ratio, meaning this one. If I look at the smaller triangle BCD, we are talking about the small triangle. So side upward to that, this one 30 and this one. So BD by BD divided by 30 degree in the larger triangle is this one. So BD divided by AB equals what I will prove here. I'm just thinking. This will just prove me the Pythagorean theorem, which is not going to give me the value of 30 degree. What is that?
For the smaller triangle, are you trying to find sine?
Yeah, I'm trying to find this. For the larger triangle, I'm trying to find out what the ratio between, see, sine 30 degree if I have to find out, which will be AB divided by AC. Right? I'm trying to find out if this side by this side is how much and how I can find it out. So okay, we'll come back to this one. We'll try proving this one in a simpler way. I'm just failing to recall how this is done. Let's try solving another one. Let's say 7 sine 45 degrees. Sine 45, if I have to do, that means I'm talking about a triangle where this angle is 45 degree, this angle is 45 degree, and this one is 90 degree. And when these two angles are same, that means it's an isosceles triangle as well. This is a right angle triangle as well as isosceles triangle, meaning this side is equal to this side. This is A, this is B, and this is C. When since these two are isosceles triangle, I mean this is an isosceles triangle and these two sides are same, these two sides are same. So that means this is also equal to A. Now, from the Pythagorean theorem, we know that A square plus B square equal to C square. That means A square plus A square equal to C square. So C square equal to 2A square. Okay? Or C equals A root 2. Okay? So now, meaning this one is, if I relate that in terms of C as in A, this is A root 2. Now find out sine 45 degree. Sine 45 degree will be equal to A divided by C. So A divided by A root 2. This gets knocked off, it becomes 1 by root 2. Okay. Sine 30, I'm just trying to recall how is sine 30 proved to be 1 by 2. Okay. We'll figure it out. We'll literally figure it out. But the idea was not to go into this one. The idea was to relate sine 30 equals 1 by 2. How to prove that? I'll prove that in the next class. Okay. I'm probably not trying to struggle and spend too much time on that one. We will do that. 0, 30, 45, 60, 90. So sine cos 10. See, this one is 0, 1 by 2. If we prove this one, then you will get this one also. This one we just proved 1 by root 2. This is root 3 by 2. Okay, and this is 1. 1 root 3 by 2, 1 by root 2, 0, 0, 1 by root 3, 1, root 3, infinity. So basically, if we prove sine 30 how it is derived, then you can find this value, and then we'll find out sine. So once you find sine 30, it's easy to find out the cos, because it's a complementary part of that. So that's how we'll. I'm just trying to remember or recall how this 30 translates into 1 by 2. Okay, I'll find it out for you guys. But what we were trying to learn today was this, that if I am talking about sine 0 is nothing but 0 radian. If I'm talking about 30 degree, it is pi by 6 in radian. If I'm talking about 45 degree, it is pi by 4 radian. If I'm talking about 60 degree, it is pi by 3 radian. If I'm talking about 90 degree, it is pi by 2 radian. Okay, so that's the relationship that we wanted to focus on today. Sine 30, sine and cos 30. How to derive that? I will prove that, or I will just send it to you guys offline. Any which way is fine. We have done that in the previous class. I'm just trying to recall what is the easier, simpler way to do it. Okay. Is that okay with you guys, or?
I'm fine.
You're fine. Okay. All right. So basically, see again. The focus here is whatever we learn, whatever we know about, how do we prove and confirm and convince ourselves that this is correct. So that's what we were trying to do. So we learned about the complementary angle. How do you use the complement angle to find out the corresponding value of sine and cos, that part. We figured out how do you get the value of sine 30 degree versus cos 60 degree. No, we have not. Cos 30 and cos 60 and sine 60 and cos 30, these two we have to find. I'll show it to you guys in the coming classes. I have done that in the previous class. I'm just trying to recall. Anybody who was there in the class, do you guys remember what was the clue? Anybody? You don't remember? Sivatsav, Sunarka, anybody? Nobody remembers? Dhanusri? No? Okay, you don't remember? Okay. I'll send that with you guys. Share with you guys. Okay. It's a fairly straightforward thing. Just that I'm struggling to recall that one. Okay. All right. So yeah, you remember Vaibhav?
Yeah.
Tell me what exactly it was. Just give me one clue. I'll.
So it was like a right. You draw like two, one small right triangle and one big right triangle, and then you're like trying to like combine them, and like you split them by doing half of it.
Okay.
So basically, what you would.
Can you draw it for me? Just
Like
if
what I think he said, you just draw the perpendicular like you did,
this is 30 degree. This is 60 degree.
and then there's the 90 degree.
You draw perpendicular here.
That's what he was saying, I think.
Is that what you're saying, Gaurav? Is this what I did?
Yeah, and then you combine them and you're doing a half of it. I don't know why you did that, but like you did a half of both of those triangles.
Okay, leave it for now. I will figure it out. Okay. I'm just trying to avoid going or spending much time on that one because, anyways, you would not have to prove that. But as we follow in the class, I try proving those theorems or whatever I explain. So I still owe you guys the explanation for that one. I will do that in the next class, or I will send it to you guys offline. Any which way that works for you. But so far we have only looked at how do you deal with the radians and angles same way. Okay, if you know, we learned about the circle theorems and all to find out the arc, the radius, find out the arc, sector area, or even the different theorem that we dealt with. All that we dealt with in degrees, that can be dealt with in radian also, only by knowing this relationship 360 degree equals to 2 pi radian. That's it. As long as we remember this, everything is the same. All calculation remains the same. Yeah. Now, how much time do we have? We have 25 more minutes. Give me 5 minutes. I think I can just find it out real quick.